One of the most common questions I get is about the POC process, or the proof of concept process. Once you first found a finding and you have an idea for a vulnerability or a bug, then you need to go and prove it out with a POC, or a test case that exemplifies the exact issue and the extent of the criticality of the issue that you think you found. So in this video, I'm going to show you exactly how I personally like to write POCs, a few things that I like to do, and we're going to do it with a real finding that I have just gotten the idea for, and I still have yet to really prove it out and walk through it and rectify it in an actual POC. So we're going to do that live. We're going to walk through and figure out if it's a valid finding, and we're going to see what the POC ends up looking like. All right, but first of all, of course, why should you care what I have to say about writing POCs? Well, my name is Owen, and over a year and a half ago, I founded Guardian Audits, and ever since then, we've done smart contract audits for hundreds and hundreds of smart contracts with over 1,000 hours spent on auditing smart contracts, and having uncovered dozens and dozens of critical and high vulnerabilities and writing dozens and dozens of corresponding POCs. The goal with all of the videos that I make, and especially this one about POCs, is to distill down all of that experience and give it to you so that you can ultimately become a much better auditor than I ever could be in a fraction of the time. All right, so without further ado, let's dive into this POC. All right, so I'm going to start off by, first of all, just explaining the idea that I have here and sort of walking through it in the code. And maybe you'll see it, maybe you'll agree with me, maybe you think it's not an issue, but we will find out in a few minutes actually with the POC as we go ahead and walk through and create a POC together. So first of all, if you want a high-level understanding of the GMX v2 system, go and watch my video on this channel, which is a complete overview and deep dive on GMX v2. It will give you all of the context that you need for this particular finding idea that I have and the POC going forward. So go and watch that video first and then come back if you want that context. Okay, cool. So I'm here in the GMX v2 codebase, and I have an idea that occurs during a decrease of a position. Okay, so while a position is being decreased with a decrease order and we are executing that decrease order, we end up calling into this process collateral function. And this function is tasked with a few things. Most notably, it basically decreases the collateral by the amount that you specified, and it also handles the sort of realization of your P&L and how that affects your collateral and ultimately the accounting in the pool. And so there's a few interesting key points here that are going to add all together and sort of create this finding. So first of all, let us just quickly explore basically how they're computing what the P&L is if the trader is in a profit versus if they're in a loss, and how this affects the pool. So first of all, we have a adjusted P&L. We don't need to worry about, adjusted versus regular P&L at this particular moment, but essentially if the trader's P&L is negative, e.g. the trader lost money, they will go into this block here, or else if the trader has realized a profit, they will come into this else block here. So in this else case, we have the P&L amount for pool, which is actually what the pool is going to be losing when the trader is in profit, right? This case is for the position being in profit. So this is the opposite of the position P&L. So in this else case, we will have a positive adjusted P&L. So this means that this will be a negative number. So essentially, this P&L amount for pool is a value taking tokens out of the pool, right? And we don't need to worry about this, difference in adjustment and this diff amount for this particular finding. What we want to pay attention to is this swap here. Now notice that the swap happens and we swap collateral profit token to collateral token. So this will only happen if the profit token is different than the collateral token. We can see that there is a assigned output token, and this is the collateral token. and there is a secondary output token. And the secondary output is basically used only if we are unable to consolidate these two tokens into the collateral token, depending on what the trader's P&L token is. So essentially what this swap attempts to do is it basically attempts to take that P&L token, and if it's different than the collateral token, swap it to the actual collateral token. And then that way, if it was swapped, then we could just add this to the output amount. And remember that the output amount is in the output token, which is the collateral token. And a key feature here that we want to really dig into and remember is that when we do this swap, we are going to be taking money out of the current market that the position is in. So you can see here in the swap, we have this parameter that's being casted to a bank, and we'll just very quickly go into this swap function and have a look, and we can see, so we have a length of 1, so we don't go in here, and here we see if the bank is not equal to the first in the swap path market, I think actually it will be the same. So the market token swap path market equals, this is the same. So actually we don't go in here, but what we do is immediately, basically, if we skirt past all that stuff, essentially down here, what's going to happen is we're going to apply delta to pool amount. Okay, and this is for the market that the trader has opened a position in. So what we're going to do is we apply this pool amount out. That's the values.P&L amount for pool that we were just looking at, right? We have the profit amount. It is essentially the P&L amount for pool. There's some adjustment. We can just think of it as the P&L amount for pool we were just talking about. That is getting decremented from the pool amount. However, there is an edge case here. Now, first, before we talk about the edge case, let us talk about, normal operation. How is this supposed to work? So we're decrementing this from the pool amount, the opposite of the pool amount out. So the opposite of what the trader basically is credited with after the swap. That's what's getting decremented, right? In a swap, you have tokens coming in, tokens going out. You need to remove the tokens going out from the accounting of the pool. So what happens is when we calculate this P&L amount for pool, this is on the values. The values are going to get returned from this whole function, and we're going to go into decrease position utils. This is where we initially call into this, and we get the returned values, right? Okay, so the values are important because they do the accounting up here. This is where they apply the P&L amount for pool. This is where they actually account for it. So in this else case, the trader's profit is positive, the P&L amount for pool is negative, and it's in the P&L token. Here, this is where they apply the accounting for that. This is where this negative value in the P&L token for pool is subtracted from the pool amount. This happens after all that swap has happened, right? So when we talk about a swap, tokens need to go into the pool, tokens come out of the pool. So if we think about the accounting here, if I've got this circle, we could just say the circle is our market. If we're talking about just doing that swap, we have the tokens that are going into the pool, tokens coming out of the pool, and then we have the accounting for that. And so if we look at what the accounting is doing here, if we just walk through step by step, what we can see is we do a swap with the P&L amount for user. We can think of this as the same thing as the P&L amount for pool, just the inverse, right? So the P&L amount for user is the amount coming in here. So here's the P&L. That's the amount getting deposited into the pool here. But where did it come from? Well, first it literally came from the market. So what needs to happen is this needs to be decremented from the market before we take those same tokens, put them back into the pool, and swap them out, right? It's a little complicated to think about, but if we just have a regular realizing of profit, then if we have a market here, if I realize my profit and there is no swap, then I just take my P&L out of the pool. The trader gets their P&L and they're happy. If there is a swap, then basically I take my P&L out of the pool. This is in P&L tokens. We put it into the pool and we swap it out for collateral tokens. So where does this P&L get subtracted from the pool, right? This is exactly what we were just looking at. This right here, we apply delta to pool amount. So it's an interesting situation where they're doing the accounting for this swap after the swap has already happened, right? So the swap happens in here, and this is all inside of this function up here, process collateral, that happens right there. So it's an interesting situation where they do the swap before they've actually accounted for those tokens being taken out, right? This is a negative value being taken out of the pool. So of course there is an edge case that we had called out earlier, which is where, well, hey, the balance of tokens in the market is not exactly accurate during that swap because you haven't accounted for this P&L amount being taken out before you literally putting it back in. So they've actually solved that issue. They have a temporary key that does the accounting for them before this happens, and so we don't need to worry about that, and we don't need to get distracted by that. But there's an edge case here that actually ruins the accounting entirely, I think. So let's walk through it. If we go to decrease position collateral utils, there are some edge cases on a liquidation. So what does this mean? This means that the collateral was not enough to cover fees, as well as the potentially negative P&L, or the P&L could be positive. So in this case, a very key aspect is that we go into this get liquidation values function, which is just down here. And interestingly, in either of these cases, specifically this one is the one that we'll look at here, as well as this one, you can see we're resetting the P&L amount for pool. And you might already see what the issue is, but essentially what they are doing here is they're saying, well, the remaining collateral was negative. We need to prioritize paying of the funding fees. And that's exactly what they do. The issue here is when you have a position that was in profit and then got swapped like this, right? So right here, this swap happens. So tokens, that P&L amount was taken out of the pool, and then they do the swap, put them back in, swap them out, swap's fine, but you never end up accounting for those tokens being taken out of the pool because you just reset the P&L amount for the pool down here or in here. So we will never end up coming here and apply delta to pool amount. This is their whole accounting system for the P&L amount for pool. Well, you will do it for the value that was reset here, but you won't do it for the value that was supposed to be taken out for the swap. So the fix would be to, before you reset this, make sure to apply delta to pool amount for the amount that was supposed to come out for the swap and then was put back in for the swap, only in the cases when it was actually swapped, right? So, okay, now that we've done a deep dive on what we think that finding is, and we've sort of tried it out, let us see if it's true. Let's write a POC for it, and let's find out together. Let's see what this ends up looking like. So I know before I'm even going to just start writing code, I'm going to basically scope out what this POC wants to look like, right? So essentially, I need to get into a case where we need to have profit, but it needs to be liquidatable. And this is totally achievable with lots of fees and things like this. So let's see. Position realizes profit. So we want to be in profit. So first thing, trader opens a position, right? And notably, the P&L token not equal to the collateral token. That's exactly how we're going to get into this swap, right? And actually do the swap. Is the P&L token has to be different than the collateral token. So then after that, what do we need to do? We need to build up a bunch of fees. There are many ways to achieve this. I'm going to do it with just borrowing fees that build up over time, essentially to make the position liquidatable even when in profit, which is a completely valid edge case that we will see can occur. So that's what we're going to do. Then we're going to execute the liquidation. We are going to execute the liquidation and see what happens. And then when we get to that point, we'll go into what I expect to happen, and we can see that. So first of all, we need a trader to open a position. So let's just copy paste, right? Let's get some stuff set up. So first of all, I'm going to steal from this other POC we have here. We need a user deposit amount. So the user is just depositing tokens into the market. Cool, there we go. And then we need a trader to open a position. So I'm going to copy this. And of course, you can roast me, and please do roast me in the comments for not using Foundry, but you certainly do not want to rewrite the entire GMX v2 test harness in Foundry. So we're using Hardhat today. So here we are. Should have an open position. Let's just do await get position count. And let me see, I think we need to give this like the data store or something. Yeah, the data store. So we'll give it the data store. Data store. So we should have one position opened here. So, all right, so we've just done a yarn install. We're going to do a hard hat test. And let's see. Favorite thing about the GMX contracts is that they take a world record amount of time to compile because there's over 100. Okay, so we have compiled 132 Solidity files and our test passed. So we have a position open. I don't even know what position we did open. We just copied that. Let's see what we got here. We got the size is 25,000. Let us just increase that a bit so we can get more fees more easily. And the initial collateral amount, let's just make it like 10,000. So we're going to be pretty lean. What is this? This is a 50x leverage. I believe the max set for liquidations is 100x. Okay, so we are creating a USDC backed long. So if we're longing ETH USD, the P&L token is Ether and the collateral token is USDC, right? So we've successfully done that. We have our position open. Now what I'm going to do is we need to build up a bunch of fees. So I know we have to set a bunch of things in the data store. We need borrowing factor. Okay, so classic copy paste. We're going to get all of these borrowing factors, borrowing exponents, stuff like this to basically activate borrowing fees in the system. And then we need to await time dot increase. Let's see if we have any. Yeah, we're going to do 7 days. We'll try this. We'll see what this does here. And yes, so now we should have a function here imported. Let's see, to execute liquidation. So let's see an example, and we're going to do another classic copy paste and put that here. Okay, so we are executing a liquidation now. For our long, the collateral token needs to be USDC. It is going to be user 0. This is the right market. We want to be in profit. We want to be in profit. And so it could even just be a little bit of profit. A very small amount of profit. So that's what we'll do. We don't need a gas label. And let's see, I don't know if this is going to be enough borrowing fees. You might say that the keeper will liquidate the position much faster than fees are able to build up like this, but there are cases where the user can like if they're in profit, they can remove their collateral such that there's not actually real collateral that's backing it fully, because the profit is actually counted as collateral, which is another questionable decision which could lead to other things. But anyways, for the sake of the POC, we're going to just build up a ridiculous amount of borrowing fees just to see if this scenario is possible here. So let's see. If I run this, I don't know what I'm going to expect to see here. I think it would probably be, I don't know exactly how much in borrowing fees were built up. We can go ahead and log it, or we get an empty order. We have user 1 here. User 1. Let's see. Okay, great. So position should not be liquidated. Right off the bat, I'm literally just going to try to eyeball it and just get it to a position where it would be liquidated. And let me make sure I did this. Looks like the right market. Let's see. So if we did something ridiculous, this should certainly be liquidated at this point. Fascinating. So let's see what we did here. Let's see. We can set these at the beginning just to be sure there's nothing messing around. Beyond that, I'm going to go in and we're going to log the fees. That's what we're going to do. So we will import the trusty, the hard hat console, and we're going to log the borrowing fees. Fees.borrowing fee. We'll do amount. This should be in the collateral token. So we can do that. And then let's log what the collateral amount is up here. And that's going to int. So let's see. Okay. Log this again. Wait forever for the contracts to recompile. And I'll see you in a second. And that's right. So we actually aren't even going to be getting here because the validation isn't going to let us get there, because we are validating the liquidation before that. We are looking at this, and then we come in here, we look at the fees, and then let us log these fees. And what I want to do, I want to log that, and then I want to look at the remaining collateral USD. And this should be an int. So we're going to console.log int for this remaining collateral USD. Okay, so we've got some more realistic factors here that I've basically found from some other borrowing fee tests. I think that's what's been throwing us off here. Okay, so I need to be adding a deposit amount for the short token to actually pull off the swap. Otherwise, the swap is going to be failing. So we need to basically give liquidity for the swap, right? And there's quite a lot of ether. So I guess what I'll do is we will bring that down to only 1,000 ether, and then let's have some USDC to match. So 5 million USDC, something like this, at a price of 5,000 per ether. So we're gonna have 6, and so we're going to deposit short, and then this is the long. And now let's try what I've done here is I've basically logged was swapped, and I think with a ridiculous amount of borrowing fees and with liquidity on both sides for the swap to happen, I think we're going to, yes. Okay, great. So I'll explain what we did here really quick, and then I'll explain what the result is. So basically what I've done is, right, we've added enough liquidity for the swap to actually happen, and then also I've just made the borrowing fees pretty ridiculous just to be able to get this working at all, right? So here we are, and now let's look at what's happening, right? So we're seeing an invalid market token balance revert. And so if we go ahead and look for this in the contracts, we can see this is thrown in several places. So the market token balance function, so when they validate market token balance. So this is done after any order is executed. They validate the market token balance. So this is sort of like a last ditch safety check to make sure that you at least have the minimum amount of tokens that you expect, right? So this includes stuff like the collateral amount, the impact pool amounts, the claimable collateral, claimable fees, and of course the pool amount, right? So everything, all of the tokens that should be in the pool, we are validating that they are in the pool. So, of course, with this scenario that I described where we are not doing this accounting in the pool amount, where we're subtracting this because we're resetting the values.pnl amount for pool, this is not getting subtracted, which means the pool thinks it has more tokens than it really does, right? Because this withdrawal didn't happen, but we still basically deposited these tokens in, right? But we just didn't account for the withdrawal. So now we're just doubling tokens. And of course, when we validate that the pool amount actually has all these tokens, it's going to be like, whoa, no, I mean, you didn't just double the ERC20 tokens in this contract. You just doubled what you were expecting in the pool amount key. So what's happening when we execute this liquidation is we are essentially failing that validation. And so what we have here is an unliquidatable position, right? So to fully have this, somewhat clean as a POC, we would expect, so I'll wrap this in expect.to be reverted with custom error. Why is this yelling at me right now? I think I need another one of those. And then please autocomplete reverted with custom error and errors. And what we need is this string of the error. And let's see. So here we go. We're going to run this and see, is that exactly where this is getting thrown? And it is, right? And we can see the logs that I've been doing to debug this. So we have, the first iteration of our POC, right? This is the POC that proves to us beyond a shadow of a doubt that there is an issue when a position in profit is liquidated like this, right? So it's in only a little bit of profit, and we do this swap, right? We come into the else branch. This is for positions in profit. We do the swap because the profit token different than the collateral token, and then that accounting does not happen because ultimately we come in here and we can log, we can do, let's see what we can do. We can, to prove this to ourselves that it's not just some magic that I'm waving here, we can say in get liquidation values, and then we can, I think what will be really interesting is if I believe, so I don't think it's going to be more than funding fees, but we are certainly going to come in here. So what we can do is we can log, I think it would be really cool to log the values.pnl amount for pool, and we can see exactly the amount that we are overwriting. All right, fantastic. So we can see we go into get liquidation values. We're logging the P&L amount for pool, and it's this negative value, right? And so we're overwriting this negative value right here. It's getting overwritten literally right here to some positive value here. And so this is never getting accounted for in this decreased position utils when we apply delta to pool amount. This got overwritten. It was supposed to be that negative value. We were supposed to take those tokens out of the pool, right? We're supposed to take these out of the pool, but we overwrit that value, so we don't do that, and essentially that accounting is lost. And so we end up with the invalid market token amount, and thus the revert. And so basically that is our POC. The next steps that I'm going to do is, find a little bit of a more realistic scenario, but that is initially how I sort of walked through, and you saw it, it wasn't, exactly just put everything together. You had to do some debugging and sort of figure things out and get them to work and work with the test harness and sort of log as you go, right? But this is going to help you understand the contracts as you go, and you're actually running the code, executing the code, and logging and seeing how everything functions as you go. And so I hope that you could see from this my sort of ideation process, and after I spot something initially, I really try to come and flesh it out and see exactly what it looks like in code. We like to scope out, write comments first, and then sort of fill in. You could see, we did a lot of copy and pasting and stuff like this, but this is the POCing process. There's not really too much to it. It's really just about working your way through your idea and getting it down onto a test file, but that is it. So if you're looking to join a growing community of auditors who are also finding stuff, writing POCs, and submitting findings in contests and reports and anything, and you would like to get the opportunity to connect with these other auditors and potentially join up to compete in team audits where you can work with others on a real audit and get rewarded for your findings, then go to lab.guardianaudits.com and apply to join our community of auditors. And lastly, of course, if you're still not 100% confident in your Web3 security auditing skills, I collaborated with other top tier security professionals in the field to bring you exactly what you need. If you're trying to go the paid route, if you want to sort of accelerate your learning in the space, and money is, something that you're really willing to expend to do that, then I 100% recommend the course in the link below. It will take you from literally just knowing Solidity, a little bit of Solidity and blockchain Ethereum knowledge, to being a complete Solidity smart contract auditing Chad in as efficient of a time as possible, really. So if that's something that you're interested in and you're looking to go the paid route, then you can feel free to take $50 off with the link in the description below. All right, without further ado, that is all for this time. I'll see you in the next one.